Welcome to The Explainer. Today, we're going to pull back the curtain on the complex world of digital maps and see how they turn a whole lot of digital noise into a perfect symphony of location data.
So let's kick things off with something we've all been through. You pop an address into your phone, you follow that little blue line, and you're in the wrong spot. It's so frustrating, right? But there's a very specific reason why that happens.
The problem really boils down to this. Location data is a total mess. It comes from all these different sources, and it's often inconsistent, it's messy, and it's full of duplicates. You might have Main Street, or Main ST, all talking about the exact same place. For a computer, that's just pure, unfiltered chaos. But what if you could step in and, like a conductor at a podium, take all that noisy data and arrange it into a perfect symphony, a single, unified, perfect map? Well, that's exactly what a system called GIS Orchestra Places is designed to do. It has this incredibly smart pipeline that takes all that chaos and brings it into harmony, creating one validated, super accurate source of truth. And just like any great orchestra, this one has its different sections. You've got the database. Think of it as the string section, using PostgreSQL with a special geospatial tool called PostGIS. Then you have the automation scripts. That's the conductor's baton, right? Directing the whole workflow. And the entire performance is guided by a musical score that a computer can read, which lays out every single step with absolute precision.
All right, let's get into the nitty-gritty. The first movement in this whole data symphony is all about getting ready, tuning the instruments.
So the process kicks off by pulling in raw data from two main places. The first is this huge collection of places from Foursquare, and the second is a reference dataset from OvertureMaps. Think of OvertureMaps as the official sheet music, the authoritative guide for how things should be. Now, to get this raw data ready, the system takes it through three really critical steps. First, it just loads everything into the database. Then, it pulls out every single unique street name it can find. And finally, and this is a key part, it normalizes all that text into one consistent format. And this normalization step is where the magic really starts to happen. It takes all those messy versions we talked about, Main Street with the period, Main Street with weird spacing, and turns them into these clean, machine-friendly keys. This is the secret sauce for getting everything to match up later. Okay, so the instruments are all tuned. Now we get to the heart of the performance, the street matching duet. This is where the two datasets, Foursquare and OvertureMaps, have to find their partners. And really, this is the core challenge of the whole thing. For you and me, it's a no-brainer that Main Street and Main Street are the same. But how in the world do you teach a computer to figure that out, especially with all the possible typos and abbreviations? The way it solves this is pretty brilliant, actually. It uses this progressive three-foes strategy. First, it goes for the easy wins, the perfect, exact matches. Then, for everything that's left over, it uses a really clever algorithm called trigram similarity to find things that are close matches. And finally, it looks at all the potential candidates for a street and picks the single best one. So instead of looking at the whole word, it breaks the text down into these little 3-character chunks. Then it just compares how many of those chunks two strings have in common. It's a super powerful way to see how similar two pieces of text are, even if one has a typo or a slight variation. Okay, so this automated process is really, really powerful. But let's be real, it's not perfect. Algorithms can still get confused or make mistakes. So what happens when the computer just isn't sure? Or worse, gets it plain wrong? This is where the human in the loop comes in. It's so important. The system basically says, okay, I'm not 100% on these, and it exports all those uncertain matches. Then a real human expert sits down, reviews each one, and gives it a thumbs up or a thumbs down. You can't overstate how vital this human in the loop approach is. You get the speed of the machine doing all the heavy lifting, but you get the intelligence and common sense of a human to guarantee that final accuracy. I mean, this is the step that makes sure an ambulance finds the right street in an emergency. It's that important. All right, so all the streets are matched. They've been validated by a human. Now it's time for the grand finale, the final performance, validating every single address point on those streets. And to do this, the system runs this last, super rigorous set of quality checks. First up, it matches the actual building numbers, to make sure 123 Main Street doesn't get mixed up with 132. Next, it actually calculates the physical distance between the matched points.
This is huge for knowing if the pin is on the right building or across the street in a park. And lastly, it hunts for any duplicates that have the exact same coordinates. This stops your map from showing two coffee shops stacked on top of each other.
But the most crucial part here is that spatial distance analysis. It gives you a hard number, a quantitative score for how good each match is. It tells you if a match is within a couple of meters. We're talking high precision, the kind that gets your rideshare right to your door, or if it's way off, like over 100 meters away, which is a huge red flag that could send your delivery to the next block over. So after all that, the tuning, the matching, the human review, the final checks, what do you get? The result of this whole orchestration is a single, clean, validated, and incredibly reliable set of map data. It gets packed up into a standard format called a geopackage, so it's ready to be used in pretty much any mapping application you can think of. So here's the big takeaway. What you're seeing is a transformation. It takes this cacophony of thousands of messy, duplicated, totally unreliable records, and it turns it all into a single, harmonized, and trusted source of geographic truth. And that is what makes our world work, from logistics and navigation to critical city services. And that leaves us with a final thought. This whole approach, orchestration, automation, and that critical human validation, it isn't just for maps. I mean, think about it. What other kinds of data chaos do we have in our world? From messy medical records to complex financial data, what other symphonies are just out there waiting for a conductor?